Hi, so in this section, we're going to find a confidence interval um, with respect to a population proportion. And so what we're going to do is essentially have a population proportion in which we'll have some margin of error, and it will be we can estimate that the population proportion will be between a lower bound and an upper bound. So it's similar to the mean, except now we have a proportion. So the point estimate for a population proportion P is the sample proportion. And so the point estimate for proportion is similar that we discussed in chapter 7, where X is the number of individuals with the specified characteristic and N is the sample size. So sometimes the p hat is not always given to us. So make sure to make a note. Sometimes this is given to us as a percentage. So sometimes we have to look for that. Either it's a percentage, proportion, but remember the keywords inside. If it's a mean, it will give you a mean and a standard deviation. If it is a proportion, it gives you a percent, and you won't see any words of mean or standard deviation. Okay, so let's go ahead and look at some registered voters in Quinnipiac University poll. So of the 1,783 registered voters, 1,123 were in favor of the death penalty. Obtain a point estimate for the proportion of registered voters nationwide who are in favor for the death penalty and round your answer to 2 decimal places. So the first thing we need to notice is that they gave us a sample size of 1,783. And so that means that X would be the number of people that had the characteristic that we wanted to observe. So we wanted to see that they were in favor or opposed to the death penalty. So this one said that 1,123 were in favor. So the point estimate for the proportion of registered voters who were in favor means that P hat is going to be equal to X over N. And so that's just going to be the 1,123 divided by 1,783. And that is equal to, if we put it into the calculator, we get a good proportion of the voters. And so rounding to 2 decimal places will be 0.63. This could be a larger percentage, more than half, and maybe because this university has a certain political party that it favors the death penalty. And so it just depends on the location and maybe the belief system in that environment. Okay, so if we wanted to construct and interpret a confidence interval for population proportion, it's pretty much the same as the mean, except now we're just doing a proportion. And so back in chapter 7, remember we had those like preliminaries. Well, we still have those no matter what. Like they're with us till the end now. So we still need to make sure that product is greater than or equal to 10 and the sample size is no more than 5% of the population. The nice thing about the population proportion and estimating it is that we can say that the mean with respect to the sample proportion is the population proportion. And the standard deviation is this nice little square root. And I believe we've seen before. So to construct the confidence interval, notice that we have a margin of error. It's with respect to the z-scores now, right? This is our MO, right? Our MOE. And we are not going to be doing this by hand. If you choose to do it by hand, that would be totally your discretion, but I encourage you to just use the calculator. And so that's why right after this, in the next page, you'll see that I have a calculator steps. So if you go to stats in your calculator and press calc and then go to tests, you're going to see the 1 prop z interval, which is A. And so notice we have to kind of go down, scroll down a little bit right here. And so prior, remember we did the the t interval in the previous section, and now we're doing 1 prop z int, which is 1 proportion z interval. So the ints are all intervals, and don't worry, you may ask if we're going to use all of these, and we are. So 1 prop z int means 1 proportion given and a confidence interval. Okay, so taking the same example, let's go ahead and obtain the 90% confidence interval for the proportion of registered voters who are in favor of the death penalty. So there's a couple of things that we need to go back and look at. Remember that we have this preliminary step, right, part 1, and then if those are satisfied, we can go ahead and look at the distribution. We do know though that the p hat is this quotient right here, right? Okay, so the first thing we'll want to do is note that our p hat is 1123 over 1783. The next thing is we want to go ahead and do the preliminary and do part 1. Right, and remember the first part of part 1 is making sure that the sample size of 1,783 is no more than 5% of all voters. So do you think 1,783 is less than or equal to 5% of all voters? I think so, because our population is a little over 300 million in the United States. So definitely yes. The second part with only proportions is making sure that NP times 1 minus P is greater than or equal to 10, right? So let's go ahead and take 1,783 times the P hat, the P, and which is the 0.63. Times 1 minus 0.63. So we'll go ahead and just do that in the calculator. Let me do 1,783 times 0.63 and then parenthesis 1 minus 0.63. And I get 415.6. So 415.6 is definitely greater than or equal to 10. So what does this tell us? Well, this tells us that we can assume the population is approximately normal. But recall number 1, 1i, where the sample size is no more than 5% of all voters, tells us that we have independence. Right, so there's a couple of things this tells us. They don't tell us the same thing, they tell us different things, and if those are satisfied, then we say, okay, now we can go ahead and assume that normal curve and find the confidence interval. And so now what we want to do, now that these are satisfied, now we can go on and find a 90% confidence interval. Okay, if we want to do this, then we need a few things, right? We know that the confidence level is going to be 90%, which is 0.9. And then X is equal to the number of people who are in favor of the death penalty. And the sample size was that 1,783. registered voters. And so we can go ahead and go to the calculator and evaluate. And what we're doing, again, I just want to keep reminding you of what we're doing now. We're taking samples and now estimating a population proportion, right? We're finding an interval in which the population proportion of all voters, all in favor of the death penalty, lie. And so if we go to our calculator and we'll go to stat and we'll go to tests and go to that A, which is the 1 props z int, hit enter, and a nice little menu comes up. So let's go ahead and put in how many voters were in favor of the death penalty, which was 1123, and the number of voters that were registered. Confidence level was 90%, and then hit calculate. So here we can go ahead and let me go ahead and drag this over. And so we can see that the proportion of the population is about, we're going to round to 2 decimal places, so 0.61 to 0.65. So the numerical answer is 0.61, 0.65. And that's what it means mathematically. But if I had to talk to somebody about this, so we could say that the Quinnipiac University is 90% confident that the population proportion of voters in favor of the death penalty is within 61% to 65%.